Hello. I'm Ban Young Koo. In this presentation, I'd like to introduce one of my journal articles. Its title is Addition of Reduced Graphene Oxide to an Activated Carbon Cathode Increases Electrical Power Generation of a Microbial Fuel Cell by Enhancing Cathodic Performance. I am the leading author of this article, and my academic advisor Saki Jong is the corresponding author of this paper. Several other researchers participated as co-authors as shown on this slide. The order of this presentation is as follows. Introduction. Microbial fuel cells are innovative bioelectrochemical systems that are being developed for an energy-positive wastewater treatment process that generate electricity from the organic waste with the concurrent wastewater treatment. In MFCs, exoelectrogenic biofilm on the anode decomposes organic matter and releases electrons, which move to the cathode through an external circuit, and an oxygen reduction reaction occurs on the cathode catalysts. Platinum has been used as a typical cathode catalyst for the oxygen reduction reaction in the MFCs, but its high price is a bottleneck for commercialization of MFCs. One of the most promising alternative catalysts for platinum is activated carbon powder. However, activated carbon has lower catalytic activity for oxygen reduction reaction, and the performance of AC cathode was improved through various physicochemical treatments. In this paper, we intend to improve the performance of the cathode by adding reduced graphene oxide to the AC cathode. RGO is a carbon-based graphene structure material with high surface area and electrical conductivity. The hypothesis of this study was RGO addition to the AC-based cathode would improve the cathode performance, and the ultimate purpose of this study was to find an optimum RGO amount replacing carbon black in ratio. Materials and methods. RGO purchased a product manufactured by oxidizing and reducing graphene oxide powder. MFC was composed of a single chamber, and the bed volume was 28 milliliter. A carbon fiber brush was used as the anode, and after inoculation, it was sufficiently matured for more than 1 year at an external resistance of 100 ohms. As for the cathode, activated carbon and conductive carbon materials were attached to the stainless steel mesh surface using a PVDF binder. The projected area of the cathode is 7 cubic centimeter. 50 millimole of phosphate buffered salinity was used as the electrolyte, and 20 grams per liter of sodium acetate was injected as the substrate. The combination of activated carbon, carbon black, and RGO was formulated as shown in the following table. The following is the experimental method. The thickness of the cathode was measured using a vernier caliper. To test the cathode's own performance, linear sweep voltammetry was measured under abiotic conditions. Electrode potential and power density were measured through LSV polarization test under MFC full cell condition. The reduction peak of the cathode was investigated through cyclic voltammetry, and the internal resistance of the cathode was investigated in detail through electrochemical impedance spectroscopy. Results and discussion. First, the cathodic linear sweep voltammetry test. RGO 15 showed the highest electrochemical performance in all cathodes. As for the current density measured by LSV, RGO 15 was the highest, 13.08 ampere per square meter, followed by RGO 5, RGO 30 and RGO 0. RGO 0 having no RGO showed the lowest performance. RGO 15 produced a 35% higher maximum power density, 21% higher optimum current density, and 10% higher maximum current density than those of RGO 0. Maximum power density on average in the MFC was in 2642 mW per square meter for RGO 15, which is 19%, 25% and 35% higher than those of RGO 5 and RGO 0. Optimum current density was in 9175 mA per square meter for RGO 15, which is 21%, 21% and 32% higher than those of RGO 30, RGO 0 and RGO 5, respectively. Maximum current density was in 19,348 mA per square meter of RGO 15, which is 10%, 19% and 21% higher than those of RGO 0, RGO 30 and RGO 5, respectively. The lowest cathodic polarization resistance detected in 42.6 ohms for RgO15, comparing with 49 ohms for RgO30, 49.7 ohms for RgO0 and 67.2 ohms for RgO5. The ratio of cathodic polarization resistance to internal resistance was 94 to 95%. The internal resistances were 44.8 ohms for RgO15, 51.8 ohms for RgO30, 52.2 ohms for RgO0 and 66.4 ohms for RgO5. The optimum external resistance, producing a maximum power in an MFC, were 45.0 ohms for RgO15, 49.5 ohms for RgO0, 53.5 ohms for RgO30 and 73.0 ohms for RgO5. Optimum external resistance in each MFC condition with a different cathode was similar to its own internal resistance. The anodic polarization resistances were almost similar among the four cathodic conditions, because the two brush anodes were used for the duplicate MFC tests. Cathodic polarization resistances accounts for approximately 95% in the total internal resistance, with the remaining part of anodic polarization resistance. To provide more realistic and practical power density values, an MFC was operated at its optimum external resistor, and its power density value during the operation was averaged. In the optimum resistance operation, RgO5 showed the best power and current production, and RgO15 showed similar performance to RgO5. Average power densities were highest in 1063 mW per square meter for RgO5, followed by RgO15, RgO30 and RgO0. Average current densities during the optimum resistance operation were highest in 3896 mA per square meters for RgO15, followed by RgO5, RgO0 and RgO30. The maximum and minimum currents in cyclic voltammetry were compared. RgO15 was the highest, producing a current of 26.7 mA. The reduction peaks for RgO5 were at -131 mV, RgO15 at -130 mV, and RgO30 at -183 mV. On the other hand, there was no reduction peak at RgO0. Therefore, the addition of RgO promotes the oxygen reduction reaction of the cathode. Ohmic impedance and charge transfer impedance were investigated through cathodic electrochemical impedance spectroscopy. The ohmic impedance at all cathodes was 5 to 7 ohms, and there was no significant difference. The charge transfer impedance of RgO15 was the lowest at 26.3 ohm, and the charge transfer impedance of the RgO-added cathode was low. Therefore, the addition of RgO accelerates charge transfer of the cathode, and improves the performance of the cathode. The structural characteristics of carbon materials were investigated. Activated carbon has a randomly porous structure. Carbon black has an electrical conductivity of 250 millisiemens per centimeter, but the particle size is irregular with 0.8 to 8 micrometer. On the other hand, RgO has a flat 2 dimensions crystalline sheet structure, and has an electrical conductivity of 760 millisiemens per centimeter. Therefore, the mixing of RgO with activated carbon improves the electrical conductivity inside the catalyst layer and improves the interconnectivity, and thus the cathode performance. However, the thickness of the RgO30 cathode was 832 micrometers, which was thicker than the general cathode thickness. As a result, RgO30 was cracked on the surface, which affected electrochemical performance of MFC. The cathode thickness was thicker as the amount of RgO added increased. Conclusion. In our study, RgO replaced Cb in the 4 different weight ratios of RgO to Cb. On performance, electrochemistry defined the optimum replacements for maximum power production in MFC. In the LSV polarization test, RgO15 showed higher maximum power density of 2642 mW per square meters, followed by RgO5, 2124 mW per square meters, RgO30, 2120 mW per square meters, RgO0, 1955 mW per square meters. In the optimum resistance operation condition, RgO5 showed best performance of power and current production. In the EIS test, RgO15 was the lowest in cathodic impedance, followed by RgO5, RgO30 and RgO0. In the LSV test, RgO15 had the highest current density, followed by RgO5, RgO30 and RgO0. In the CV test, current production was highest in RgO5, followed by RgO15, RgO0 and RgO30. RgO has higher conductivity than that of CV. For future research, finding a low-cost material replacing RgO would be valuable. Thank you for your attention. Don't forget to click that red subscribe button and give me a thumbs.